The title of our paper is called MorphBrush Spatial Drawing with Morphable VR Brush using Generalized Cylinders. 3D shape modeling have been an active area for decades. Nowadays, models are still primarily visualized and being interacted with on desktop screens, but recent research shows that VR could be another option. Previous reviews show that users generally prefer modeling in 3D space. VR have immersive interactive interface that users directly see and interact with objects using hands or controllers and monitor with a mouse. They don't need to learn a lot like complex shortcuts in Blender than in desktop. VR modeling could be a very promising research direction. We now introduce two representative studies about modeling in two different research fields. The first one is Adaptive Brush. Adaptive Brush system allow users to easily control the ruling direction through translational motion while drawing freeform ribbon-like strokes. But however, freeform ribbon-like brushes suffer from unwanted position jitter as their orientation is coupled with the trajectory, making it difficult to maintain stable control during drawing. Furthermore, continuous changes in rolling direction are hard to control, leading to failures when attempting to draw twisted ribbon shapes. Such ribbon-like brushes cannot support the drawing of watertight shapes, such as those shown in Figure 4. The second one is 3D sweep. 3D sweep is a research that allows users extracting a generalized cylinder from a single object by dragging mouse for 3 times. So by several 3x-N operations, it can create many shapes. However, you need an image as initial input, which means users cannot create the shape freely. In spatial drawing of ribbon-like brushes like Adaptive Brush, they make use of ribbon-like brushes because they naturally provide normal directions, which is naturally good to represent surfaces. In sweep-based modeling methods, such as 3D sweep or curve sweeping in Blender, the common point of those is uplifting, or they call a 2D curve or segment to generate 3D surface. We summarize some similar researches in two different fields to the two works we introduced. But however, having common features could also mean they have common issues. In spatial drawing of ribbon-like brushes, we can extend the section shape to draw more complex things like tube, vase, inverted-type shapes. Freeform ribbon-like brushes also have issues on drawing some twisted patterns. For sweep-based modeling, many desktop modeling tools are most difficult to learn, as 3D sweep relies on external input. They lack a simple way to create a sweep-based shape while keeping the controllability. Sweep-based modeling is widely and frequently used by artists, which has the very same idea called Generalized cylinder method. In this way, artists can quickly build neck, limbs, even animate hairs and face meshes in this way. This idea is commonly used and not very complex. Therefore, we want to use VR to lower the barrier to help users quickly build shapes using this concept while keeping the cross-sectional shape and sweeping paths under control. To echo the above concept, we build a system. This video demonstrates how to use the system to create wine bottle. First, we create a cross-section of the bottle body. The cross-section is the top-down view of the outline. Next, we define its deformation near the neck of the bottle. Then we subsequently place the cross-section and its position using several drags. This drags position from the sweep path while the slider controls the deformation of the cross-section. Now by these operations we generated one bottle. We have 3 interfaces in total. Drawing interface is the core interface of our system. We can select a base section shape to draw before performing a stroke. We can drag to place a section while controlling its position and rotation. We can also use a bar slider to morph the section before placing a section, which is defined by Morph Editor, placing the section sequentially to gradually form a 3D shape until the shape is done. When drawing any shape, the skeleton of the shape can be considered as a sequence of nodes. Each node consists of a rotation, position, and section shape information. With blending widths of the lining blend are controlled by user of UI interfaces. Section shapes are defined after the context of simple graph. The simple graph defines how the points are connected on the segment, and each point has coordinates by placing points and segments. Base shape editor defines the graph itself and the coordinates of the points, while the morph editor uses non-graph to define the new coordinates for each point by moving existing points. Interpolation is required to generate a continuous and smooth shape between any 2 neighbor nodes by inserting subnodes between them. We use different interpolation methods not only on the position, rotation, but also the coefficient k for the smooth variance on section shape in the formula. The experimenting environment is as you see. We have 2 experiments. Experiment 1 required participants to use the system to complete 3 creative tasks, each revolving around a specific theme, and to provide evaluations using SUS and CSI. Task is guided using a demonstration. We achieved overall CSI score at 4.08. The second and the third item here received very high ratings. The second item indicates that they were able to immerse themselves in the creative process, and the third item indicates that they feel the results were worth their effort. Our system achieved SUS score at 67.29. This is merely acceptable. We scored too high on some negative items. For example, we received a near moderate score in the negative evaluations of need support here. Meaning that many people believe the system requires upfront technical support to use our system. Oops. Our system. These are results drawn by users in the system in experiment 1. We selected 2 results from each of the 6 themes. Although the shapes are very rough, based on the rough appearance, the drawn shapes is still good with the themes. Experiment 2 requires creator to try out this system and other implemented ribbon brush system to create works on the same topic and to read the preference of each system, explaining why they give such scores and why the scores differed. The results show that users have a stronger preference for our system compared to the baseline, which uses a ribbon-like freeform drawing method, such as gravity sketch and cave painting. The questionnaire results indicate that the preference stem from the section customizing function or editability on the section we provide. Due to various reasons, such as short duration of user participation in the experiment and the limited number of participants, the shape drawn by the participants are insufficient to demonstrate the system's potential. Here, I present some shapes drawn by myself. These shapes possess a certain complexity while being expressive. Our contributions are as follows. We contribute a VR workflow for the generalized cylinder methods, allowing users to define structural cross-sections and drawing volumetric shapes in VR. Compared to studies using ribbon brushes, we expanded the shape of cross-sections and modified the paradigm of drawing to overcome some issues inherent in freeform drawing methods. We achieved better preference results compared to other baseline systems in preference experiments. However, our system also has many shortcomings and design failures. Some problems stem from the underlying representation. For example, we require the user's drag direction to be consistent along the sweep trajectory. Otherwise, an anomaly like the one shown in Figure 1 will occur. Also, when a cross-section degenerates into a line segment, dragging in different directions may result in same visual effect, and the different internal storage structures lead to unpredictable subsequent generation results. These issues could be the blame of our low SUS rating. Solving this problem and even designing better interaction patterns are our future work. Thank you for your listening, and that's my presentation today. We already released the source code of this project. If you want to check the source code of this project, you can scan the QR code on the screen. Thank you.